Hi everyone, and welcome to Blue Marble Learning Team. I want to ask you, have you ever noticed that when snow is falling, sometimes it's light and fluffy, sometimes it falls really, really slowly, sometimes it's fast, heavy, and like wet, and sometimes it's like big, thick lumps or small individual flakes. Now, if you've noticed all those things, maybe you've also wondered how that might impact where snow actually winds up on the ground. Does it actually influence where snow accumulates, where snow falls, and if so, what other factors are influencing how the snow gets onto the ground? That is what we are going to investigate today with our snow survey. So the question is, how do we measure the snow? You're only going to need three things. The most important being a ruler, a pen or pencil, and your recording sheet. The ruler needs to be 0 side down. So we're going to need to flip this. So you want the 0 centimeter mark at the bottom. You're going to take it perfectly vertical and you're going to dunk it into the snow. Now, I hit something right there. If I hit that, is that the bottom or the ground? Probably not. So I'm going to need to push a little bit further. That was actually just a bit of hardness in the snow. So I'm going to keep pushing, pushing. I may meet a little bit more resistance. I want to push through it to make sure it's actually into the bottom of the snow. And I've met the ground there. So on my way through, I'm at 2 resistant locations that I needed to puncture through. Luckily, I have actually got a 40 centimeter ruler here. So you're going to, if you have as much snow as we do, you're going to want to get a meter stick if you have more than 30 centimeters of snow. Now, when you actually go to take your measurement, just like if you're measuring water in a beaker, you need to get your eye down to eye level. So you're going to look right down and you're going to look and see where is that snow on that ruler mark. You don't want to compress the snow. You want to measure the very top snowflake that you can see. The snow we have today is really light and fluffy. So it may be that you can actually see a couple measurements, the millimeter marks on your ruler. You want to measure the top one that's just over top of that snow. So right here, we are actually at 40 centimeters and 5 millimeters, so 40.5 centimeters. And we're going to record that on our sheet. Now, is taking one measurement real science? What if that location, you can kind of see maybe that there are these little droplets. Some locations are a little bit shallower than other locations. So of course, with science, we have to redo the measurement. So you take your ruler out, and I put it right back in the same hole. No, of course not right back in the same hole. You want to take a measurement within a 30 centimeter area around your first hole. So I'm going to choose over here. We're going to push the ruler in. Again, we're meeting that layer of probably melted and refrozen snow. Go through that. Oh, meet that other hard layer. Go through, go through. Oh, and there we are again. Now, I did push my fingers in a little bit, so this is one reason why going right down to eye level is important. Because if I read right near the ruler, I'm going to get 39 centimeters of snow. But if I take my head down, I'll see that it's actually at 40 centimeters and 4 millimeters. So 40.4. So I'm going to write that down. And with science, third time is always the charm. You want to take 3 of the same measurement in the same area. So take your ruler out, choose another location, straight in. Well, that one only had one hard bit to get through. And then take your measurement. Head down. And this one actually is 40 centimeters exactly. So I'll write that down and I'll be able to take the average of the 3 measurements for this location. Now, is that everything that we need to do when we're recording snow? No, we do need more information. Like, where are we? What's the date? What's the weather like? what factors are around me that may be influencing why there's this much snow here. So today, I'm going to write down my date. I'm also going to write down the last time it snowed, which for us was actually just last night. I'm going to write down my location, which is kind of on the edge of a very light forest in the side of a yard. So I am on top of grass here, and I know that because I've seen this not in the wintertime. And the current weather is clear skies, a little bit of wind, and I'll check the temperature once I get inside. I can also check and see what the temperature and the weather was like when the snow was falling, because that's going to probably influence why there's so much snow here compared to other locations. Finally, I'm going to take some notes about what might be around here that could influence snowfall. So I'm going to note that there are a couple buildings, there's a forest, there's actually a little bit of tree cover right on top of us. And I'm going to take all those notes down because it may influence why there's more or less snow here than other locations we're going to measure. So now that you know what you're doing, why you're doing it, and how you're going to do it, I want you to think about a couple questions. First, does snow fall evenly? When it's falling from the cloud in the sky, does it always fall evenly over the landscape? If yes, then why do we get more snow in some places and less snow in others? If no, then what factors are influencing that distribution of snowfall? Think about these before you go out and measure your snow, and maybe even make a hypothesis or a prediction about where you think there's going to be the most snow and the least snow in your yard. When snow falls, be it that wet, thick, quick falling snow or the soft, fluffy, slow falling snow, there are things that are going to impact where it lands and how it accumulates, besides exactly what it looks like and what type of snow it is. Now, just looking around me, can you think of anything that's going to impact where the snow is going to land? Maybe the trees behind me? What do you think? Is there going to be more snow where I'm standing or more snow in the forest? Yeah, you're right. The trees are going to interfere with the snow getting into the forest, so it's likely that there's less snow in there. Our snow survey can help us figure that out if we take a measurement both inside the forest and outside the forest to confirm our hypothesis or our theory. The other things that are going to influence where snow lands is the wind. The wind, although the snow may be coming straight down, can move it from one side or the other. And because of the wind, any obstacles, buildings, fences, other small objects like picnic tables or benches can also impact where the snow is going to land. On a small scale, but it still impacts it, as well as maybe even hills and slopes in the landscape. What else do you think is going to be a factor in where the snow accumulates? And before you go take your measurements, can you think of where in your area that you're taking measurements has the most likely chances of having the most snow and where is going to have the least snow? Think about maybe forming a little hypothesis before you go out and actually measure it. So today, when we are measuring snow, we are going to choose 4 locations that we think the snow has not been disturbed by humans. So you're avoiding areas where it's been snow blown, shoveled, walked on, maybe peed on by an animal. You want some fresh fallen snow, or at least snow that hasn't been crumpled. Once you have that snow, in your 4 locations, you're going to do measurements just like we just explained to you. Take your ruler, take 3 measurements, and make sure to get down at eye level to record your findings. And the reason I chose this location for our first measurement is because of this. we have an obstacle in the way of our snowfall. And you may already notice that the snow is actually reducing how much is there until you get under the obstacle. Obviously, the picnic table is keeping the snow off of the ground, but that doesn't start right at the edge. It actually starts maybe about this far away. And that's why I want to take a measurement right here is, seeing how far this influence actually goes. And I'm going to take it from just out of what I can visually see the influence being. So I'm going to get down, vertical, and right into the snow. See if that's the ground or a hard chunk. Ooh, it's a hard chunk. Okay. And like I mentioned before, you may want a meter stick. We are slightly over our 40 centimeter, 5 millimeter maximum of our poor little pink ruler. But for today, I would hopefully go get a real meter stick if I was really wanting this science to be a-okay. Today I'm going to fudge it a little bit. So we're going to call that 40 centimeters and 7 millimeters, so 40.7. With our 3 measurements, I'll write them down on my paper, take the average when I'm back inside, and we're going to move on to our next location. So the second location I've chosen in this backyard is the base of a very small hill. I'm actually going to measure at the top next because I want to see if the snow accumulated at the bottom of the hill is the same as at the top. One thing you can do is if you don't have a super long ruler or a meter stick, but you have a lot of snow like we do here, you can use a tape measure. I will caution you though, tape measures bend, not like these rulers. So you want to make sure you use something solid like a stick to get all the way to the bottom, then insert your tape measure so you know you've gone through all those hard layers, which it will have more trouble getting through. So our measurements at the bottom of the hill. This one's actually interesting. I'm not meaning hard layers of snow where it likely melted and refroze again from older snowfalls, but what I am feeling is vegetation or grass underneath. It's actually a little bit springy. You want to make sure that you push your ruler down as far as you can go. Let it spring back just the tiniest bit, but you want to make sure that you have crunched that vegetation down so you are measuring from the ground and not like 5 centimeters up on top of some grass. Now, let's go to the top of the hill. We are at the top of our small hill, going to take our third set of measurements. When we choose the 4 areas around the field, forest, property that we're taking our snow measurements on, we want to make sure we're getting different types of environments. So, my next location is going to be by the trees in the forest because that's a new area in this section. But the top of the hill, the bottom of the hill, and near that picnic table were 3 great locations to get an idea of the snow distribution in this backyard. Writing those down and we can move on to our next location. So, we do recommend you take at least 4 different snow measurements in 4 different areas of the yard or playground or park that you are measuring snow in. This is one of the spots that we have chosen, which is right beside a forest and in a forest. I'm actually going to count that as 1 measurement because I want to take a couple more. So we're going to do 5 in total in this backyard where we are. So let's start with on the edge of the forest, and then I'll just walk back in there and take 3 more measurements to see what the snow's like in there. Let's go look in the forest. So we can already tell that yes, there's a little less snow in there, but not as much as maybe we would have thought. If our forest was maybe a little denser or I had gone further back in, do you think I'd get even less snow? I'm not going to measure it today, but maybe you can with your experiment. Okay, now we have all my measurements. It's your turn. Go out to a yard, collect measurements of snow depth in at least 4 locations, remembering to take 3 measurements at each location. Once you're done that, make sure you collect all the other data that you need, like the date, the temperature, the weather conditions, when it last snowed. Then we'll meet back and discuss what we found. Great job. I hope the weather wasn't too cold for you while you were collecting your measurements. Now, I'm not sure exactly what you collected, but you were with me when I did the collections in this yard, so we can discuss what I found, and then you can work up and see what you found and why you think the snow distribution was the way it was in your yard. So, you can see the yard that I was sampling behind me. We sampled right by the picnic table, at the bottom of the hill, on top of the hill, and in the forest, and right outside the forest right behind me. What I found was actually that the most snow, or the deepest amount of snow, was by the picnic table. Not what I was really expecting. The next deepest location was on top of the hill, followed by the bottom of the hill, with the two locations with the least amount of snow being outside the forest and then just inside the forest, which I did expect. Now, why did I find what I found? Do you have any ideas? What factors might have influenced the fact that there is more snow beside the picnic table? So one thing you may not have known, because I'm the one who did all the research on the weather, was that when it was snowing, the snow was actually being blown by the wind from the north, which is that direction, towards you, which means the picnic table was getting the snow blown at it. And if you ever think about how wind and water blow around an obstacle, when it hits that obstacle, it slows down. And if it's carrying something in it, that means it's going to deposit it on the lee side, the back side of the object, which makes sense why there's more snow on the lee side of the picnic table. If I really wanted to test that hypothesis I have for why that has more snow there, I would want to take a measurement on the other side of the table to see if there's less snow there, because we would expect the wind to kind of erode out or not deposit the snow there. The top of the hill might have more snow because of a similar reason. It was getting snow that came over top of the forest and deposited there. And then right outside the forest and in the forest is getting less snow because the wind's coming this way. And so the snow went up and over the forest and then deposited onto the yard. There are a whole lot of different ways and a lot of different things that we could hypothesize that really happened. But with only 5 measurements in this yard, there's a lot of questions still out there. So after you make your hypotheses and your predictions and kind of think about why you found what you found, you might want to go out and take more measurements to see if those predictions are correct. Now, if you really feel like it, you can actually make a topographical map of your snow distribution. It might look something like this. Or this. You don't have enough data to fully know exactly how the snow is distributed. But a topographical map of snow is just showing depth of snow, where each line is a slightly different depth. Kind of like a hill, or a typical map would show you that there is elevation gain. This is optional, obviously, but I think it's kind of fun to predict and then go and see if your predictions were correct. One thing that I did mention is I measured my snow right after the snowfall that morning. The factors that influenced my snow were a lot of factors related to when the snow was deposited. But have you ever thought about the fact that snow can be influenced by factors after it's already deposited? What if it rained? Or what if it was really, really, really windy and the snow was already on the ground? What if there was snow already on the ground or an obstacle underneath the snow? How are these factors not related to the actual snowfall? How are they affecting where there's more snow and where there's less snow? Particularly, I'd like you to think about the rain one. This is an interesting question because rain has heat in it. So when it hits snow, it's going to melt it a little bit. What do you think that's going to do to the depth of snow? And you know what? You can actually analyze this yourself. Take some snow from outside in a container and bring it inside. You can do your own experiment looking at two new things. You can look at how snow melts and take measurements as the snow melts in your warm class or your warm room. And you can also look at how snow responds when it gets rained on. If you have a sprayer with cold water in it, you can spray the snow and see what happens to the depth of snow and how it changes. These are fun things you can do to understand snow a little bit more in the warmth of a building, where I think I'm going to go right now. Have fun with your experiments, and I'm excited to see what you find out.